Good morning, children. Today we are discussing about the structure of functional group present in alcohol, phenol and ether. First we will discuss the structure of functional group present in the alcohol. For that I taken the methanol. The methanol structure is C bonded with 3 hydrogens and OH groups. So here we are discussing the structure of functional group. Which one is the functional group? OH is the functional group. So here we are discussing the structure of the OH. So OH, first oxygen. Oxygen, how many bonds are there? Oxygen having lone pair bonds are 2 pair is there, 1 and 2. 2 pair is there, and the bond pair is how many is there? 2. This one and this one 2. Total how many bonds? 4 bonds. Total how many bonds? 4 bonds. So 4 bond means we know that is a tetrahedral structures. So what is the structure of this functional group? Tetrahedral structures. So tetrahedral structures, this is the tetrahedral structure. This is the tetrahedral structure. The tetrahedral structure, the bond angle is 109.5 degree. So what is the actual tetrahedral structure is the bond angle is 109.5 degree. But if you look at this one, 108.9 degree. The angle, bond angles of these are 108.9 degree. The question arising why? So what is the actual? 109.5 degree. This is the actual tetrahedral bond angle. But here what is having 108.9 degree. So what is the reason behind that? Because of these, look at these lone pair electrons. There is a ratio is the lone pair repulsion is greater than the bond pair repulsion. So here the lone pair electron, look at they are when we draw the structures, it is like that. The 2 lone pair, here 2 lone pair. So these lone pair electron, there is a repulsion is there. The lone pair, they are repulsion. So what happening? They are, if it is like that, it is the for that repulsion they are becoming like that. So for when it is the repulsion is more, that is affecting the lone pair. That is the bond pair angles also. So that is the reason this was decreased. These angles, these 2 angles are now 109.5 actual, but it is decreased because of this repulsion. The lone pair electron of these 2 electron repulsion. For that, these decreasing these bond pair electron angles. So I hope all of you understood. So once again repeating, the lone pair electron of the oxygen, 2 lone pair, they are having repulsion. So when they get repulsion, that disturbs the bond pair electrons, these 2 angles. So that is the reason it was a little bit decreased. So the force is acting here also. So that is decreased a little bit. So now the OH is attached to the sp3 hybridized carbon. The OH is attached to the sp3 hybridized carbon. Next one, the bond angles. The bond length 142 picometers. What is the angle? What is the length of this oxygen and the carbon? 142 picometers. So this is the structure of the alcohols. The functional group when the OH is present attached to the alcohol. So the hydrocarbons. So the alcohol structures we discussed. Now let's discuss the phenol structure. Phenol. If you look at these bond angles, 109 degree. So it is a little bit only less amount. There is the variation between the actual and the phenol. Actual how much? 109.5 degree. But here what is 100? Because why it was only little amount the variation is there? Because of this bulky group present, the repulsion is not affecting much in these angles. These bond pair. So that is the reason it was a little bit amount was only the variation is there. Now look at this bond angle, this bond length. The bond length is 136 picometer. How much? 136 picometer. 136 picometer. Why it was decreased? Look at here how much? 142. Here what is 132? Because these lone pair electrons, they are delocalizing towards, that is the resonance effect. That is the delocalized towards here. So that is the reason these single bond act like a double bond. Partially it is a double bond. So that is the reason the bond length was decreased, 136 picometer. And the carbon, what is the hybridization of this carbon? sp2 hybridization. The OH group attached to the sp2 hybridized carbon. Now let's discuss the structure of dimethyl ether. That is the ether group. Ether group, look at the oxygen attached to the two bulky groups. So for that reason, what happening? Their bond angles are 100.11 degree, 111.7 degree. It is, look at these, how much it is having the bond angle? 109, 108.9 degree and 109. But here, look at here, it is increased. The bond angle normally these two cases decreased, but these cases increased because of two bulky group attached in the both sides. So when the bulky group attached, it is the bond pair repulsion does not affecting these bulky group bonds. So that is the reason here the bond pair repulsion is more as compared to the lone pair. So that is the reason the bond pair was little bit increased. So 111.7 degree. And it is attached to the sp3 hybridized carbon. The alkoxy groups attached to the sp3 hybridized carbon, and the bond length is 141 picometer. There is not much different, only little bit different. What is the difference? 141 picometers. So this is the structure of functional group of alcohol, phenol and ether. Thank you.